secret for it to be able to actually put my own inputs in. What I'm going to be talking about today is looking specifically at the value, not just of digital twins, it's called a digitalisation within transportation in particular through the life cycle. I'm actually going to be in a panel discussion myself about how we're going to be doing some of the cautionary tales, challenges. I heard the question come through, and so we should be able to tackle that in the O's bar. So yeah, I'm going to be looking through the life cycle from planning, design.
It's usually that's the first scoring for me.
Yeah, planning, design, structure, operations. Just as a few quick examples. So the first example here, I'm going to take us through two basic sites, specifically to West Belmar, where they're trying to optimize transportation for existing infrastructures in place. So they decided to build a model that was a combination of the existing transportation network, the proposed network for both rail and road, and the land usage existing and proposed as well, and then run simulations, what-if scenarios on top of that to try and optimize the flow of report through the regions of place. As a direct result of the simulations, they managed to improve travel efficiency, just the average transit times by 15%, and they've actually reduced their carbon emissions by 21,000 tons at the same time. So a great success story there in terms of the work being done. It's kind of a similar example, again, from the planning phase that's in place, looking at geotechnical issues now as well. So we're moving over to Germany now, to German high-speed rail, where they were trying to minimize environmental impact, digging 50 kilometers worth of tunneling, unleaving varied geological formations. So what they had to do there is combine the data together. Can you jump back to the previous slide for me? Okay. To combine the data together in order to be able to understand how that geology is going to settle the change over time for those tunnels, to build not just a fit-for-purpose design today, but a sustainable piece of infrastructure going into the future that cope with the different forms of geological events. Now we'll move from there on to the design board in turn. The clicker is not working, by the way, so if you click to the next slide, please. From the design world, we're going to jump from here over to Jakarta in Indonesia. What they've actually done here is actually built its BIM model initially, and then they've built some of the digital twin for design and construction from that phase as well. As a direct result of doing that and being able to do that multidisciplinary collaborative work was taking place between the track teams, the bridges, tunnels, signaling, electrification, stations, platforms, everybody working together in that common environment. They've managed to reduce the costs associated by $185 million US, and they've shortened their schedule, there's a design schedule, by 6 times. They've also greatly increased the quality of the deliveries that come. Typically, deliverables come through these processes and there's rework taking place. The amount of rework is down by 40% as a result of consistent collaborative mechanisms, methodologies to actually help increase that, improve that efficiency and make sure they get it right first time, first place. If you jump to the next slide, please. To the top. What we're actually finding, this is not a use case or a success story, this is just a kind of an example of what's going forward into the future. We're seeing more and more that we're actually getting carbon analysis becoming an integral part on projects to be run. So it's actually moving away from being a separate overhead, separate team doing this, to actually be embedded as each part. So within the design process, we really do believe that we're actually going to see this carbon capacity be seen this right the way through to be able to support us delivering up to a sustainable infrastructure, not just in terms of sustainability construction into operations, but the impact is going to have on it, which was discussed in the panel previously as well. So next slide, please. We move from here into construction in terms of success stories there. If you're going to jump over to the next slide. And from here, where you move to Melbourne, Australia. Can you turn to the next slide? Thank you. From here, we're turning over to Melbourne, Australia. The project is growing here. They're actually looking at replacing all of the 11 crossings inside Melbourne, which was actually going to detrimentally impact travel between two sides of the city. It's going to impact the road network and the rail network at the same time. So what they decided to do was create a digital replica, a digital twin of the entire construction process that they were going through. Not just the start space of the end space, every crate lift, every piece of work day you place, every position of safety, every walking route, every vehicle movement running all the way through. This was actually updated dynamically from the crews in the field, so that any changes took place were actually updated in the project. The impact is assessed real time, and then that could be used in the daily site briefing. So rather than a generic briefing, it could be perfectly attained to the exact position of all the site requirements that are in place. As a result of doing this, they saved hundreds of resource hours in the work they were doing. They reduced their modelling time by 60% because they were getting the right work done, like getting that collaboration done in the first place. And as a byproduct from doing that, as part of that process, they managed to reduce their carbon footprint for the build work was being done by 30% as well. So multiple successes in terms of time, in terms of risk, and in terms of carbon. Next slide, please. So we're now finally to get operations and maintenance score. You can switch to the next slide. Thank you. There's a few examples from the look at here. First, slightly closer to where we are now, we're actually in Dubai with RTN, where they've actually built a process where they've connected their asset environment, their design environment, through to their operational world and their enterprise asset management systems by adding in tag information, that tag intelligence flowing the designs right way through. In order to do this, their audit times of processes will be reduced by 90%, and their accounting processes, again, tightened down by 87%. So huge efficiency changes, improvements by being able to actually bring these data together and not spending the time searching data, rework on. Next slide up now, please. Now we're moving on to nearly the last example. This is actually Broad Street Bridge over in North America, in Minneapolis. It's a historic bridge which is got cracking problems associated with it, and they were get ones to do is actually close down the asset. They had no CAN modems associated with it, but they wanted to digitally transform. So what they've done is use LiDAR and drone pics to actually survey a bridge, and they can do that computer. They're combining then with IoT data with subsurface data. They can run data, but they're going to the thoughts as well, and using all of those integrated data sets to allow digital inspections of the assets. On top of that, they're actually using AI, targeted AI, that's being trained to look, for example, for cracks in concrete. So it can identify the cracks, the length, relative width, and priority list. Not to take away from the engineers, but to say to the engineers, these are the areas that I see, I think you should be looking at. It is still an engineering decision of what is actually done at the tail end of that. They've reduced their telephone inspection time by 30%, but it also means going forward with subsequent inspections. They can be all the way tight, so yours changed over time with this complete digital snapshot of a bridge. Next slide, please. The last example you're going to here is actually SMRTU Trade, Singapore, a company that I used to work with very closely. They've actually digitally transferred the maintenance with their go. So they take their design, the as-built data, their usage data of the tages, their measured up data, the visual inspections, integrated all of that together to the rate of deterioration to try and move themselves, again as was mentioned in the previous panel, from a reactive world, is broken, I need to fix it, through a proactive and predictive world of these into deteriorating, we need to do something about it. They've increased the reliability of their rail network by 500% as a result of this. This is for 40-year-old network. Next slide, and then if the switch over from there to the last slide, just one last thought. This is coming from our incumbent CEO, Bentley Systems. The focus that underpins all of this is actually data centricity. So rather than time-based work that's taking place, paper-based work, or even moving file-based work, treating the data as the center of all of the work that's taking place, all the discussions that are taking place, making sure you've got the right data, the decisions that are being made to be informed but better outcomes far end to deliver safe, reliable, sustainable infrastructure.
9 sentences there. And up there.
Thank you. It's 2 years, 9 seconds.